Hello, I'm Emily Parsons and I'm a PhD student from the University of Greenwich in the UK. And this is my presentation about our paper, How Secure is the Home? Assessing human susceptibility to IoT threats. So COVID-19 has affected the lives of everyone at this point, and the world of technology is no different. So many organizations in many different sectors have had no option but to allow their employees to work from home, and with many ad hoc cyber solutions. So these organizations have been pushed into seeing the benefits of working from home, such as the low costs and increased productivity. And so many domestic environments are starting to merge this home and work setting together, with a lot of cyber assets now being both personal and business oriented. And so because everyone's working from home in their own space, monitoring this cyber risk composes a much more difficult task. So within the home, there might be unregulated cyber behaviors and devices which could be exploited to impact home inhabitants and also businesses. So this can obviously pose as an issue, as IoT, as we know, has a history of not being very secure. In a 2019 report, one of the key findings from Avast was that over 40% of smart homes contained at least one vulnerable device, one more easy potential target. Not only this, but in March 2020, BitSight observed the famous Mirai malware as being at least 20 times more frequent in a home network rather than a corporate network. So at its core, we can identify the key problems within the work from home environment to start understanding how risks can be modeled. And we start with the modeling of the human factor towards risk within this home setting. So the goal of this paper sort of starts to address how risk can be modeled within a domestic environment, considering IoT and the work from home landscape, as COVID-19 has changed how many companies operate. So this paper starts with the modeling the human factor towards risk. And so IoT by nature, as we know, is heterogeneous and unstandardized, which poses problems when considering security regulations and standards. So part of this problem stems from the human behavior towards IoT and the security of IoT. So this also means that we need to model user accountability and address how the home inhabitants can be self-secure simply by addressing their behaviors. So within the related work for risk assessment solutions, there are various frameworks that have been proposed already. IoT Risk Analyzer, which quantifies the likelihood of attack while considering vulnerable entry points and connectivity. There's also graph theory that uses well-known risk concepts. And then there are also the articles that analyze the risk of a specific smart device. On the flip side, there are also the other frameworks that start to focus on this human factor, such as Octave Allegro, sorry, I can't say that properly, which identifies the critical cyber and physical assets, while considering this idea that humans are the greatest risk. And finally, there is the articles that assess risk within the privacy of information within IoT and the role that the user plays within this area. So when it comes to user behavior, there are some clear themes that we found in the related work. So it's clear that IoT is becoming more popular, which means it's becoming, and it's also becoming more normal to use, such devices as smartwatches. But with this growth, many users are now tend to undervalue their information, their data, and thus ignore the need to actually protect it. Not only this, but some even think that there are no significant risks within IoT, as they expect systems to be designed with this security in mind. And it can be seen that this innovative technology to autonomize daily life is often welcomed by a lot of homes. However, this security aspect is often neglected in favor of convenience. So what we do differently is focus on the user's ability to increase the cyber risk within the home, starting to target these behaviors and initiate change. So our smart home behavior and attitude risk model is a starting point to address the human factor of risk and reinforce the importance of identifying these positive and negative cyber behaviors. And the model's parameters come from various papers, and obviously we address the how the user behavior can increase and decrease the expected loss within the home. So we use this we use NIST to identify this high level risk formula with the parameters as you can see on the screen, which we break down to explain the user behavior. So we then assign, under each of these risk concepts, we then assign a sort of a sub-parameter, if you will, to each of these concepts. So first of all is the human factors that can affect the likelihood of an attack occurring. So first of all is the risk appetite, which involves the potential risky or risk-adverse behaviours that users seem to accept. And this was chosen based on the assumption that risky behaviours are vulnerable and can be exploited so that an attack may take place. On the other hand, is security familiarity, where a user may or may not be familiar with a device's recommended security guidelines. And this was chosen to represent likelihood based on the assumption that this awareness towards the device security contributes towards the types of safeguards that are put in place. And without these safeguards, the attack is more likely to happen. So second is the human factors that affect the success of an attack. So the user's ability to perceive a threat requires that they understand that there is a threat, being able to correctly identify this. So once this takes place, they must also know how to prevent this threat so that they can stop or de-escalate the threat. This was chosen based on the ability of the user to stop an attack from being successful, so that that different parts of an attack path are not successful. Next is the potential impact. So the types of impact are influenced by asset valuation. However, we can show that behaviours do impact the impact by using the previous parameters that can affect this, such as cyber and emotional consequences. And finally, the effect on the efficiency of the safeguards. So the level of safeguard implementation is also based on the other parameters to show the correlation between these risky behaviours and the level at which a necessary safeguard is used. So within our paper, we use our model alongside HSG48, which considers the human factors within risk and within risk assessment. This is how we approached our use case. So in the context of the smart home, this means identifying the problematic behaviours and attitudes, identifying the impacted assets and the types of impact, and then deciding if the existing safeguards are enough. So our case study is based on the Amazon-owned Ring security system, which contains smart cameras and doorbells. And back in 2019, in December, there were many reports of hackings which took place whereby an attacker, they could access multiple accounts by finding email addresses and passwords online due to a prior data breach. So for our case study, we present an example potential attack path as seen here, which involves assets such as personal information and obviously the smart camera. So in short, each attack objective is required to reach the end goal. And so they need to first get the username and password from this data breach, which found online. And then they need to actually access the account itself. And if they're successful in accessing the account, they then they can then use the camera's speaker function to then conduct voice phishing to deceive the victim and potentially steal money from them. So in the next few slides, I'll discuss these parameters in the context of 3 household types: low, medium, and high risk towards this attack event. And it is important that this is towards this event and not a generalized kind of note, as it were. So in the best case, we can see that a lot of the behavioral attributes here are very non-risky, secure-oriented behaviors which contribute to a safer home. Therefore, the likelihood of this attack path even occurring is lower, and this is due to the amount of good behaviors where positive attitudes and behaviors potentially lead to these good practices. And on the flip side, we have the high-risk household, which is the direct opposite of the low-risk household, which has a lot of limited security practices, and also there's this idea that the impact is much greater, with direct cyber, emotional, and physical consequences being much more likely to occur. So in the final part to this, the medium risk home shows this more ranged, realistic setting where there are both positive and negative attributes which can be identified simply by breaking down the behaviors that we see in place. Each event, or each attack event within the attack path has its own likelihood of occurring depending on the controls and the behaviors shown. For example, in this case, since the inhabitants reuse passwords, it is likely that the attacker will successfully enter the account. However, since they have a great knowledge of social engineering, it would be much harder for the final financial loss to actually take place. So human behavior is always challenging and will be different depending on the assets used. For example, the way a user approaches risk towards a smart camera will be different to how they approach risk to a smart TV. Our model is a method to start formalizing and identifying these negative risk-causing behaviors, and by identifying these, it provides insight into the potential human vulnerabilities, which can then be mitigated. So our future work requires more work into how risk can be modeled within these domestic environments. And so our next goal is to extend our work to create a risk assessment and mitigation framework that can aid the improvement of security within these domestic environments. Part of this includes the identification and assessment of user groups as well as assets to examine the risks and potential safeguards of the rapidly evolving individualistic environment. Finally, the second part to this is to model decision making to implement the best safeguards within a given set of requirements. For example, the resources that a domestic home may have. These are all of the references from my presentation, and thank you so much for listening. Are there any questions?
Okay, Emily, thank you very much for your presentation. Are there any questions from the audience?
Oh, sorry.
Should anyone make a question?
Can I just quickly add? Thank you for listening, because this was my first conference and I've been a little bit nervous. So thank you everyone for listening again.
Emily, it was a very nice. Your presentation was very nice.
Thank you.
I have to ask you something. To introduce myself, I'm Vasilis Mamalis from the Department of Computer Informatics and Engineering of the University of West of Attica. Just I spoke in Greek in the beginning, so I introduced myself again. And I would like to ask you something. Is there a modeling direction that takes into account how dangerous is how risky are the transactions someone makes from his home. I mean, it's different. Someone makes everyday Bitcoin transactions against me that I never use Bitcoin, and I just rarely use my bank accounts for banking. Is there a connection between the risk of the transactions anyone makes from his home?
I'm not 100% sure because
Could it be a connection? Could it be?
Could there be a connection? So I mean, I wouldn't be surprised if there was some kind of, connection between how we use Bitcoin, because I know that there's a lot of people nowadays that I'm not sure 100% sure what they're called, but people can remotely access people's PCs without knowing and start to mine for cryptocurrencies. I mean, potentially that's something that's we could look into, and I think that would be, I've written that down, I think that would be pretty interesting to actually have a look at as well, to kind of see if there is that pattern there, if that makes sense.
Yes, okay, thanks. Another question is how important are the network connections, how secure are the network connections in the last mile, near home, in these case scenarios? Can you
mean, so the scenarios that we came up with were more of a generic type of thing, but the sort of next step in this in the research is to sort of now consider everything else as well as this human aspect, if that makes sense. So within assets, part of the sort of